Okay, more poker hand probabilities. Again, let's think of probabilities as a numerator and a denominator. The denominator is the total number of outcomes. So in this case, the total number of 5-card hands. And that is shown in another video, the denominator video. So go check that out if you're curious about the denominator. It's 52 choose 5. Okay, so the first hand I'm going to talk about is the royal flush. The royal flush is the hardest hand to get, but the easiest one to count. Okay, so we can run through, we can look at all of them because there aren't that many. Okay, so a royal flush is a straight. It starts at 10, so it goes 10, jack, queen, ace, king, ace, and the same suit. Okay, so there's 4 ways to do it, right? So we can show all 4. Here's the clubs. Here are the diamonds. Order doesn't matter, remember? Here are the hearts. Here are the spades. All right, 4. So our numerator is 4. Now I'm going to show this in terms of combination functions just because it's good to be used to thinking of these things in terms of combination functions because that's how you want to do it for the other hands. Okay, so let's start again with a 5-card hand. And what do we need to do? We need to choose one suit from the 4. Okay, after that, there's only one way to choose the cards. So we first choose one of the 4 suits. So 4, choose 1. Okay, and then from there, okay, we know the suit here in this case is clubs. Okay, so we know all the other cards. 10 of clubs. Okay, we're showing the jack of clubs, queen of clubs, king of clubs, ace of clubs. We don't care about the order. So there's only one way to do that. Okay. Now in terms of combinations, we could say from 5, we have 5 cards that we know we need. And from those 5, we're going to choose 5, which is just 1. 5 choose 5 is 1. Okay. So there's the denominator as usual. Numerator is just 4. And I'm not even going to put that in decimal form because it's just vanishingly small. And you will, even if you're a poker player, probably never see that. Okay, the next hardest hand to get is a straight flush. So it's related to the royal flush, but just includes some more possibilities. Basically, we can start it anywhere. So it's a sequence of 5 cards, same suit, but it could start at ace, 2, all the way up to 10. Okay, but we're going to exclude the royal flush. So this is excluding the royal flush, so not starting at 10. So the highest one would be 9, 10, jack, queen, king. Okay, so in terms of combinations, let's think about the possible starting cards. So they're listed there, ace through 9. Okay, so that's 9 possible starting cards. So 9 choose 1. Okay, and then we're going to choose a specific suit. So from the 4 suits, we choose 1. Okay, and then now everything is sorted. We have our starting card and we have our suit. Okay, so there's only 5 cards to choose from here. So from our 5, we choose 5. Okay, so in this case, if we know we're starting at 4 of clubs, we know all the other cards. So we know we have 4, 5, 6, 7, 8 of clubs. That's 5 cards that we know make up our hand. From those 5, we choose 5. 5 choose 5 is 1. Okay. So that's a straight flush. It's a pretty hand, huh? Same denominator. And 9, 4, and 1. Okay. So just notice that the royal flush is excluded here. Okay. Royal flush is excluded because we're only considering 9 different starting cards. So that gives us a numerator of 36. Again, a tiny, tiny number. I don't want to even show the decimal, all those zeros. So 36 out of 2.6 million. Okay, now we're going to talk about probability of a normal straight. The easiest way to do this is to count up all the straights and then subtract these special cases of royal flush and straight flush. We don't want to count those, so we're going to just count the total and subtract these. So we'll put those up in the corner there. And we'll look at a normal straight now and start with a new 5-card hand. And we're going to think about the possible starting cards. So we need a 5-card sequence, and it could start with anything from ace all the way up to 10. Okay, now remember with a straight, the ace could be a low card or a high card. So ace, 2, 3, 4, 5 is a straight, and 10, jack, queen, king, ace is also a straight. All right, so let's first talk about the starting card. So there are 10 possibilities. We need to choose one of those. So 10, choose one. Okay, so now we have our starting card. And let's just look at an example. Okay, so we'll be starting with a 5. So we know our sequence is 5, 6, 7, 8, 9. So for each one of those denominations, there are 4 possibilities. From those 4, we choose one. So there are 4 5s, we choose one of those. 4 6s, choose one of those, and so on. So we have 4, choose one, 5 times. Okay, so there's my straight. That's my same denominator as usual. The numerator looks like this. Let's just take one of those and raise it to the power 5. We subtract out these special cases now. And there you have it. 10,200 of those. All right. And the probability is 39 out of 10,000. Okay. Or normal straight. Okay, finally we'll take a look at probability of a flush. That's 5 cards of the same suit. So, like the straight, we'll count all the flushes and then remove these special cases, the royal flush and the straight flush. So those were calculated earlier. We'll tuck those up in the corner. Okay. So we look at a 5-card hand. And first, what we want to do is think about the suit. So from the 4 possible suits, we're going to choose one. And then, once the suit is chosen, there are 13 denominations in that suit. So from the 13, we'll choose 5. And that's basically it for a flush. So here we've got hearts. Okay, we need 5 hearts. So from the 13 hearts, we choose 5, and there they are in no particular order. All right, so here are the numbers. Denominator, same as always. 4 suits, 13, choose 5. Then we remove the straight flush and the royal flush, like so. And our final answer, roughly 2 out of 1,000. Okay. Less likely than the straight. Okay, that's it for this episode.